does our nervous system send and receive messages? This response is driven by what's called a nerve impulse, an electrical charge traveling the length of a neuron caused by a stimulus. This is also known as an action potential. Every action potential or nerve impulse requires a threshold to be reached. If an initial stimulus is strong enough, for example, if it reaches the threshold, it travels along the length of a nerve cell and transmits the message to other nerve cells. If it is not strong enough, or it does not reach the threshold, nothing happens. Let's go into a little bit more depth on how this occurs. First, you must understand what is happening to the electrochemical charge inside the cell versus outside the cell. When muscles are at rest, the cytoplasm in the nerve cell inside the cell normally remains negative due to the work of the sodium-potassium pump. The sodium-potassium pump moves two positively charged potassium ions into the cell for every 3 positively charged sodium ions it pumps out. The uneven number of ions causes there to be a positive charge outside the cell and a negative charge inside the cell. Once an impulse reaches a threshold, the transport channels in the nerve cell's plasma membrane here open, allowing for positively charged sodium ions to enter. This positive charge inside the cytoplasm forces other channels in the membrane to open, allowing potassium ions to leave the cell. When these positively charged potassium ions leave the cell, the cytoplasm returns to the negative charge. This change from the cytosol turning from negative to positive and then back to negative triggers the same set of reactions down the length of an axon, like the crowd doing a wave at a football game or a basketball game. The speed at which an impulse travels depends on the amount of myelin covering the axon. The presence or absence of this myelin can mean the difference between feeling sharp pain versus a dull throbbing pain. And remember that speeds of up to 180 miles per hour can be reached when achieving an action potential.